Kubernetes is becoming the de facto standard for running containers in the cloud. All yours, Gagan.
Thank you, Ron. Thanks everyone for joining. So what we'll try to do in this talk is we'll talk about Kubernetes on Azure. Basically, the way I have planned it out is we are going to be talking about the introduction about what Kubernetes is, and then I'll try to give you an overview of how Kubernetes can be used on Azure. We'll go through some top scenarios, and then I'll leave us all with some list of resources which you guys can use and start practicing Kubernetes or trying to deploy your application using Kubernetes. So, well, with that, let's get started. I have about 40 minutes or so, so I'll try to be in the time period which is given to me and still cover the entire content. So let's start with the introduction. So as you all know, Kubernetes is becoming really as the industry benchmark for container orchestration. More and more companies and more customers which we are dealing with are now wanting to use Kubernetes. The reason behind that is that Kubernetes is the orchestration platform where you can define what your desired state of the application needs to be, and with some input from the customer, and from the user, Kubernetes would be responsible for making your application, scaling it out, upgrading it, and doing all the things which a typical administrator would have to do in a traditional on-premises environment or a VM environment. So the momentum of Kubernetes has increased a lot, and it continues to increase. And that's the reason more and more companies want to kind of spend their time and understand how they can leverage Kubernetes in their environment. So why do you want to use Kubernetes, right? I mean, what are the advantages which Kubernetes brings, maybe which a regular VM or maybe which Docker could not bring for us? So one of the most important things with Kubernetes is that Kubernetes is portable. You can deploy a Kubernetes cluster using your YAML files or using any of your automation infrastructure as a code automation tool, and deploy that Kubernetes cluster either in your public cloud, which could be Azure, AWS, GCP, and take the same file, the YAML file, and deploy it on your on-prem environment as well. So if you are an administrator, you really don't care where your Kubernetes cluster is running. All what you care is that your cluster is up and available. You can take your application pods and you can deploy those application pods. So it provides you a lot of portability and gives you an advantage wherein you can leverage your on-prem resources, and also you can leverage your resources in the public cloud. That's one. The second thing which Kubernetes brings to the table is around extensibility. Kubernetes is highly extensible in the form of where you can bring in additional tools to Kubernetes. So for example, if you have a large environment with public facing applications and applications which are dependent on backend services, your microservices and things like that, you can use something like a service mesh, and you can bring that service mesh along with your current Kubernetes cluster, and you can take advantage of that service mesh in managing your big environment on Kubernetes. So similar to service mesh, you can bring other sidecar patterns to Kubernetes, and you can extend that to give the functionality which your applications or your developers may require. The third is around self-healing, and I touched upon that a little bit in the introduction. Basically, what happens with the self-healing part is, and which I feel is the biggest advantage of using Kubernetes as an orchestrator, is that Kubernetes is responsible for scaling your applications, right? So let's say if I have an application which I'm deploying on Kubernetes, and I know that during certain periods of time, my application would have more traffic compared to other times, I can define that in my YAML file. I can tell in my YAML file what my replica sets need to be, how much I need to scale out, how much I need to scale in, and then Kubernetes would be responsible for managing that state for me. And this is going to be irrespective whether my underlying node goes down or not, because it's Kubernetes' responsibility to kind of deploy my pods across the available nodes and make them available in the state which I have desired. So that's a big advantage which Kubernetes brings to the table. Moving on, Let's do a quick one-on-one of what Kubernetes is and how you, as a user or a developer, can interact with it. So if you have a Kubernetes cluster or a Kubernetes instance deployed on, let's say, your laptop or any of your public cloud, the way you interact with Kubernetes is through the kubectl command. So the kubectl is how you issue commands to your Kubernetes cluster, and when you type that kubectl, for example, if you use the command kubectl get pods, kubectl would then reach out to the API server, and then the API server is responsible for responding back to the request you're making via the kubectl command. The API server is actually hosted inside of a master node. So any cluster which you deploy using Kubernetes is going to have a master node where all of your management plane components such as your API server, your etcd servers, your schedulers are going to be installed. And this is done at the time of installing Kubernetes. So this is going to be a common form in any installations which you do. Once the master node becomes active, it's the responsibility of the master node to enforce the desired state of your pods. So when I say that, hey, I need to do a deployment for an Nginx server, and I need 3 replica sets of the Nginx server to be available at all times, I issue the command to the API server, and then within the API server, the scheduler is responsible for deploying my pods across the across the nodes which are available as part of my cluster. The nodes, the cluster is also comprised of something which are called as worker nodes. So worker nodes are where you can actually deploy your pods. So if I'm deploying, let's say, my Nginx pod in the example which we just talked about, those Nginx pods are going to get deployed onto my worker nodes, and then as part of the cluster, it is responsibility of Kubernetes to make pod-to-pod communication available. So, for example, if I have a front-end application which needs to have back-end connectivity to a database which is deployed on my pods, there are a variety of ways how that communication can be enabled within Kubernetes. And obviously, if you're deploying a front-end application, it needs to be available through the internet, and Kubernetes has a concept of kubeproxy to enable that. And then you can also set up your own ingress controllers like an Nginx, or if you're doing a public cloud, you could use a load balancer from the public cloud and make that as your ingress controller. And we'll look into that as we move on. Moving on to the next slide. This was, I mean, what we just spoke about was a high level of how Kubernetes can be deployed if you were doing that on your laptop or on your VMs in an on-prem environment. And obviously, since you have to kind of manage the master node in this case, and you have to kind of deploy the master node, the manageability of the master node is going to be the responsibility of your administrators, which could get difficult, because in addition to your existing VM environments or whatever environments you have in your on-prem, you now have the additional burden of managing a Kubernetes cluster. So what Azure has done is Azure has abstracted that management plane, and we have created something which we call as the Azure Managed Control Plane for Kubernetes. So the things which we discussed around the API server, the scheduler, and the etcd servers, we as an Azure is going to be responsible for managing and creating that for you. So as a customer or as a user on Azure with AKS, which is our managed offering for Kubernetes, you still interact with kubectl. kubectl still reaches out to the API server. This API server is in the management, is managed by Microsoft. And then you still have the same concept of worker nodes, which are basically underlining VMs, and you deploy your pods on those VMs. So as a user, your only responsibility now is to deploy your application and manage your application, and you don't have to spend time managing the master node. So what this does is it gives you a lot of advantage in terms of how you can increase the reliability and availability of your Kubernetes cluster. Being Microsoft managed control plane, it's our responsibility to make the API server and the associated components highly available so that your applications do not experience any downtime. We are responsible for securing the management plane. So that is done out of the box for you, and you can define RBAC on your, you can use RBAC to define who is going to be using the cluster in what way, and that is integrated with Azure AD. The other thing around having a managed control plane is that Microsoft is responsible for upgrading your cluster. So if you were doing this on your own, you would be responsible for upgrading it through the upgrades which are available to Kubernetes, and you'll have to spend time and kind of have a maintenance window where you want to do that. However, if you're doing it with AKS, it's our responsibility to do that for you and keep you up to speed with a patched environment, which is going to take care of all, which would have all the vulnerabilities patched, and it will give you a secure environment where you can deploy your applications. So that's a big advantage which we have seen, and a lot of customers have already adopted AKS, and they continue to adopt AKS because it just makes the deployment of applications on containers so much easy. And one big takeaway from this is that the management plane is not charged to you as a customer. So we don't charge you for the management plane. You only pay for the VMs which you're using on for deploying your pods, which are the worker nodes. And we don't charge you for the management plane. Moving on, we touched upon the advantages of Kubernetes, which was around portability, healing, and extensibility. What we have done is, obviously, being a managed offering of Kubernetes from Azure, there are certain other advantages which gets added on because of that. So the number one is going to be around CI/CD. So as a developer, you can now take your code and you can use CI/CD practices using Azure DevOps and Azure pipelines, and you can create automated pipelines to kind of take your code from a source repository, whether it is GitHub or whatever your source repository is, and deploy it onto the AKS cluster. And you can make this as a loop, because as a developer, it's your focus is to have a place where you can deploy your code, you can test your code, and then you can make changes to that code. So we make that seamlessly easy with AKS and some of our DevOps offering, and I'll touch upon that a little bit again in my slides ahead. The other thing around the AKS advantages which it brings to the table is that we have out-of-the-box integration with Azure AD. So Azure AD being your single source of truth where all your identity is stored, you can use RBAC to control how the access of your cluster is going to be granted for your users. So that is something which is integrated with Azure AD and which will give you an instant advantage of securing your cluster right out of the box. The other thing which we bring to the table with AKS is that we have integrated it with Azure Monitor. So if you were doing a Kubernetes cluster on your own, you would have to have your own monitoring solution, and you would need to configure your own monitoring solution so that you can get some insights and metrics from your cluster and then take action on it. Whereas what we have done is, when you're creating a Kubernetes cluster from the Azure platform, on the Azure platform, we enable Azure Monitor by default. And what that does, it gives you monitoring for your containers, which are the pods which you're deploying. It gives you monitoring for your underlying nodes so that you know how your memory usage is, how your CPU usage is, and things like that. So all of that is built into the service, and you can easily view that information when you're going to the Azure portal or via the command line if you prefer to do that. Any questions so far? I'll keep going then. This is a quick matrix which actually shows what is customer responsibility versus what is Microsoft's responsibility. So if you see, the responsibility of Microsoft is to do cluster hosting, upgrades, scaling, patching, monitoring, and logging. We take care of all of that, and which is the biggest advantage we are bringing to the table with this service. In terms of the customer, you are responsible for bringing your application and and deploying that application onto AKS, and you're responsible for your own CI/CD pipelines and methodology around how you want to do CI/CD. Azure provides you certain tools to make that simple, but it's not mandated that you have to only use the Azure tools. You can still use like open source tools or third-party tools like Jenkins if you prefer that, and then still deploy your code onto AKS. Moving on. So this is the loop which I was talking about as to if I was a developer, my whole idea is how I can write my code and how I can deploy my code onto an AKS cluster and then have that continuous loop where I can deploy the code and test it. So the idea with AKS is that we have integration with Azure Dev Spaces. So basically you leverage Azure Dev Spaces, you create your code, you deploy your code to an AKS cluster, and you can continue doing that until you reach to a point where you're satisfied and the code needs to push to a source repository. At that point, you push the code to a source repository like something like a GitHub, and then from GitHub, what happens is you take your image and you deploy it into an Azure Container Registry. So Azure Container Registry is your private image registry, like something like a Docker registry, and you have the ability to make the Azure Container Registry available in all the regions where your resources might be. So we give geo-replication out of the box with the Azure Container Registry. So it again abstracts the need of having the user or the customer to bring their own registry and maintain it. So what you basically do in this example is once your code is in the source repository, you push the image into your Azure Container Registry, and then through Azure Container Registry, either you can directly deploy it to your AKS cluster through kubectl, or you could have a pipeline through Azure DevOps or any other CI/CD process which you might have, and use that to deploy your code onto the AKS cluster. And then this becomes as a continuous loop and a continuous way of how you can push your production code onto AKS and make those changes and bring that level of innovation for your customers, which they are looking for. So it's extremely easy once you start using it due to the various integrations available on the Azure platform. Taking code and deploying it on a Kubernetes cluster is actually really easy. Again, I spoke about this already. Azure Monitor is going to be enabled by default. So you don't have to kind of do anything special in terms of monitoring. We kind of make that available on the platform itself, and it'll give you good enough metrics, which you can then take and build your custom queries if you have to, or build any custom dashboards if that's the route you want to go with. Moving on to the next slide, basically this slide just shows how easy it is to work with Azure and create your Kubernetes cluster. So for example, if you're trying to create a cluster on a laptop or in a VM in your on-prem environment, there's a bunch of work which you need to do, starting from provisioning your VMs and your networks to installing certificates, using kubeadm or Minikube to install your clusters, building that trust between the clusters. However, if you're doing that with Azure, you just issue a command, which is az aks create through the command line, az being the Azure command line, and the cluster would get created for you after you provide some parameters such as which resource group you want the cluster to be in, what is the region you want the cluster to be in, and so on and so forth. You can also create the AKS cluster through the Azure portal. So it's the same experience like the command line, but it's just that you have a GUI in front of you and you don't need to issue the commands. You just provide your parameters and the cluster can get created. Similarly, for upgrading and scaling, we provide simple commands such as az-aks upgrade and az-aks scale, which you guys can use to scale out your Kubernetes cluster based on the demand which you see. It makes it really simple to do that on Azure, because if you were doing this in your on-prem environment, you would have to create a new node and then register that new node with your master node and then kind of do all the plumbing work before you can actually start scheduling pods on it. So again, makes it really simple so that as a customer and as a developer, as a user, your focus is on your applications and making those applications available to the customer. Moving on to the next one. In terms of deploying your applications, if you were deploying your applications to something like a Docker in the past, you would have to write a Docker file, and within that Docker file, you would have to define the various images which you want to use and what would be the commands you want to issue once the Docker container is spun up, and you would have to kind of have a detailed Docker file which defines how the application needs to be built, and that can get some complex many a times, and it also brings in another challenge around how you do versioning around it, because there may be some people in the organization who are working on it and some other people who are making changes, which may or may not be very easy to maintain in an environment which is very complex and big. With Kubernetes and using Kubernetes on Azure, you can actually use open source tooling such as Helm. Helm is one of the most popular package manager which is used for Kubernetes. So you can use Helm to deploy your application and manage the life cycle of your application. And it's pretty simple to use. You can just initiate certain commands on the Azure command line, and it'll give you that experience. Another thing which I wanted to touch upon here was around the ingress controller, which we just spoke about initially in the introduction. So what happens is when you're creating a Kubernetes cluster and you're deploying pods onto it, your pods are going to have different functionality. You may have certain pods which are front-end facing pods. You may have certain pods which are doing backend services and may not need access to the internet. But for any application which requires access to the internet, you need to provide Kubernetes a way so that it can go out to the world and the world can actually see that application. If you were doing this do it in your own method on your data centers or in your VM environment, you would be responsible for actually creating the ingress controller and the underlying resource which is going to provide you that ingress control. In most of the cases, it's usually an Nginx load balancer or some load balancer of some kind which you may have in your on-prem environment, and then configuring that for an ingress controller, obviously doing DNSA records and doing your custom domains and things like that. So it's a pretty involved work which would take some time to get the networking laid out so that your applications can be accessed on the internet. On the Azure side, we actually make this really, really simple for you. So when you're provisioning your AKS cluster, either through the Azure portal or through the command line experience, you can tell Azure whether you need an HTTP application routing or not. What basically that is, you are telling Azure that, hey, I may have an application which would need access to the internet, and I want the underlying resource which would enable that to be created as part of my cluster creation. So if you enable that, what happens is we would create a load balancer for you, and that load balancer is going to be available in the resource group which you define. And once your AKS cluster is actually provisioned, you can go into your AKS cluster and you can then create a service of the type load balancer, and that load balancer type is going to use the application, the load balancer which is created when you check the HTTP application routing option. So basically, you just are writing a service at that point for Kubernetes to tell it, hey, I want to create a service and expose my application through this load balancer on whatever port to the internet. So we make that whole process extremely easy. Moving on, similar things talking about how you can do CI/CD and how you can use Azure DevOps to kind of integrate with AKS and make that whole developer experience really smooth, and you can provide your developers feedback like almost immediately. I'll move on in the interest of time since we touched upon this already. Any questions so far? Just want to make sure you guys are good with the content which has been presented so far.
Yes, there were a couple of questions that I've answered. One question came up, maybe you can comment on this, is people wanting to get some hands-on labs or trial programs to test out Kubernetes on Azure.
Yes, so we have this learning website which has modules for AKS, and what I'll do is, Ron, I'll send you a link for that. I believe it's a lab where you can actually start playing with AKS, and it gives you a lab environment where you can issue certain commands and get a feel for how you work with AKS. That's one way to do it. The other way would be to kind of sign up for a free Azure account, and then I believe we give out certain amount of dollars, and then you can use those towards provisioning in AKS clusters. But I'll provide both the options to you offline, when then you can send it to the person who asked.
Will do, and I'll send it out to everyone because I'm sure it's not an isolated instance.
Right. Any other question?
No, I would just keep moving along. This is great stuff. Getting lots of good feedback on the chat and Q&A.
Cool, awesome. Moving on, what's happening in terms of security, right? I mean, anything which goes onto the public cloud, there is always a question around how are you securing it? What are the options available for me in order to secure my environment? We spoke about the Azure AD integration, which is very important when you're trying to do RBAC. Again, comes out of the box integration with Azure AD. It's up to the user and the customer as to how they want to control it. There is actually an option when you're creating your AKS cluster where you can say that you want RBAC through Azure AD. So if you enable that option, so the integration is actually enabled. Moving on, we have also integration with the Key Vault. So basically any secrets, if you're using your pod, if you're using pod secrets, and if you're trying to isolate your pods and define how your pods need to be interacting to other pods within your application stack, you can manage those keys through Azure Key Vault. There are a lot of patterns as to how Azure Key Vault and AKS can be used, and I can provide some documentation to Ron, which you guys can see and read through, which provides great information. Around networking, I think this is important, so I'll spend a minute here. So in terms of networking, we actually provide you two options when you're trying to create an AKS cluster on Azure. The two options are obviously the basic one, which is just a vanilla implementation where we create the address space for you and you deploy your AKS cluster, and you can interact with that AKS cluster if you're part of the same address space. There is not a whole lot you can do with that option. There is another option which we provide, which is the advanced option, which is based on the Azure developed version of the CNI. So what happens with that is you have the ability to bring your own address space. So you basically define what your CIDR range is going to be, and obviously that is going to be within your VNet, and then you have the ability to define where you want to deploy your AKS cluster within the VNet. You can define what subnets you need it to be in. You also have the ability to define what your service CIDR is going to be. So for example, when you create services on the AKS cluster, whether they are whatever kind of services, whether you're creating, whether they are node ports, whether it is a cluster IP, you would need the range, you would need network IP which gets assigned to that service in case of a cluster IP. So those service CIDRs can be defined as well. The other thing which we provide with advanced networking is the option to completely have your clusters to be private. If you don't select this option, then the API server which we spoke about in the beginning is going to be routable on the internet. So you would be able to reach out to that API server on the internet, which may not be an ideal scenario for many workloads, especially in regulated industries like healthcare and financial services. So what we have done is we have given you the ability to have a completely private cluster, and when you select that option, the API server and any associated resources are all part of your VNet, and there is no actually access outside to the internet for that, which makes it highly secure. So there are a variety of ways you can do networking. I mean, most of the users I work with obviously choose the advanced network type because you have the ability to define where your AKS cluster goes. So just a quick call out around here would be that when you are trying to deploy a AKS cluster in a subnet, you need to ensure that your IP address ranges which you select, are appropriate because you need to have the ability to have IPs available to your pods, because each pod needs to have its own IP. You may run into a situation where there is no IPs available to get allocated to the pods if you don't have proper ranges. So that would return a failure. So being careful about that and planning for it before deploying the cluster is actually essential. Quick note on the certifications. The service itself has various certifications to it. The list of certifications are actually available on our trust website. Quick call out for HIPAA and PCI. If you're trying to use AKS for any payment services kind of a scenario, PCI certification is going to be really important, and the service is actually PCI compliant and HIPAA compliant, amongst others, which are available on the Trust Center. Moving on, quickly talking about the scale. Obviously, scaling is available. You can increase the number of nodes which you initially created as part of your AKS clusters. So, for example, if I created a 3-node AKS cluster and I see that there is a need to increase my AKS cluster to maybe 10 because of my application load, I can do that on the fly. So you can basically issue the command through the command line, or you can go to the Azure portal and just increase the number of nodes to 10. On the back end, we will create those additional nodes for you and make them available, so that when new pods are created or new deployments are created, the new nodes would be available for scheduling. The other thing around scaling is obviously AKS would leverage the global data center reach of Azure. I mean, we're available in 50 plus locations all over the world, so you get that advantage out of the box because you have the ability to leverage our data centers around the world. The last point was around, I wanted to touch about, was around the Azure Container Registry. Azure Container Registry is geo-replicated. So before this, what would happen was you would have an ACR in a, let's say, in US East region, and if your AKS cluster is in a European region or some other region, you would have to call the image, and it would add a lot of latency to it, and it was not a very ideal scenario. What now we have done is, with geo replication, we would pick the image for your AKS clusters from the closest resource or the closest location available. So that makes it really helpful in terms of reducing the latency and increasing the speed of creation of the cluster and deploying of your applications. Moving on, this is a quick slide which shows how we work with some third-party tools around AKS. I think the main takeaway from here is that you would see in the below part of this slide, we have native solution for each of these areas, right? So we spoke about Azure Monitor for networking. We spoke about Azure CNI for the network piece of it, where you can do your VNet integration. We also have integration with VS Code and Azure DevOps, which would actually help you do integration for your CI/CD pipelines. But again, that's not mandated. It's a customer choice as to what they want to use. We have integration with infrastructure as a code solutions like HashiCorp, Terraform. In terms of monitoring, we have integration with Datadog, Fluentd, to name a few. I mean, you get the point. So depending upon whatever the user and the customers want to use, they can pick any of the solution and integrate to their AKS cluster. Moving on, I just have 3 minutes left, so I'm just going to try to cover one or maybe two scenarios just to give you guys an idea and feel for how this works. So majority of the scenarios where we have seen AKS work is around lift and shift containers and microservices. Obviously, machine learning and IoT are some of the new use cases which are coming up, and more and more customers in that community are using AKS. But majority of what I see is around lift and shift and with microservices. So if we take the lift and shift scenario and we try to see how AKS can help you in that journey. So the idea when you're trying to do lift and shift is that you don't want to change anything at all to kind of move your code or move your application from an on-prem environment to AKS or a container-based environment. So what we enable for you to do is that if you can take your application and then convert it to a image and deploy that image to container registry, we can help, or we can take that image and deploy it onto an AKS cluster. So basically the idea here being is that if you have an application, your existing application, which is in an on-prem environment, you probably are not having the scalability of the cloud, the global reach of the cloud, and some of the security which the cloud brings to the table in terms of Azure AD. And you can get benefit of all of that even without refactoring or recoding your application if you use AKS and you deploy your application onto AKS. So that is the big takeaway. This is a quick diagram which shows how that can be enabled. We spoke about the Azure Container Registry part. We spoke about the Azure Pipelines part already. If you see the call out number 3 here is that the RBAC is controlled via Azure Active Directory, and then I have my application deployed on AKS. And through AKS, I can also connect to my backend services, which could either be my SQL servers, which is a PaaS solution, or I could have a database deployed on pod, or I could have a database just running on a VM. So there are various scenarios which can be implemented, but the major takeaway being the ability to take your application and move it onto AKS so that you can get the scalability and the security which the cloud has to offer. Quickly touching upon the microservices one, the idea for microservices is that to break your big monolith application into smaller services which are independent. And these independent services can be scaled up, scaled down, can be controlled as to how they are accessed if you can deploy them independently and you can manage them independently. So obviously with AKS, we give you that advantage of using your application and kind of breaking them out into microservices and deploying it into AKS. Obviously, this is going to be a longer journey for our customers because you have to refactor your code. It's not a lift and shift scenario. So there is a developer involvement which would be required, where you are trying to refactor your code, retest your code, making sure your application functionality remains intact once the application has been converted into microservices. So again, similarly to what we saw in my previous slide, you can do the developer loop here, where you're creating it in Azure Dev Spaces, sending it to your AKS Dev cluster, making sure that your application or your microservices are performing the way you want them to before deploying it into your various environments on the AKS cluster.